Okay guys, 1.6 part 2. Welcome. My hair look okay? Good. Alright, so quadratic inequalities, that's what we're looking at here. If you remember the first part of 1.6, we did linear inequalities. Solution was like x is greater than or equal to whatever, x is less than or equal to whatever. It's the same idea, except for instead of linear, we're looking at quadratic, we're looking at parabolas, okay? So the way you handle quadratic inequality is, first thing you need to do is get 0 on one side of the inequality. After that, find the values of x that make the quadratic expression 0. Then plot those values on a number line and test the regions. You're going to find that some of the regions will be true, some of the region will be false. We're going to use that to write our solution, and we're going to write our solution in interval notation, okay? Let's get started with a fairly simple one here. All right, so this first one. Okay, this one, it says x squared minus x minus 12 is less than 0. Okay, so the first step's already done for us because we have 0 on one side of the inequality, okay? The next thing we would do is find out what is going to make this equal to 0. We're going to do that by factoring this, factor of mentioned numbers. And this factors to x minus 4 and x plus 3. And I want to find out what is less than 0, what x values would make it less than 0. To do that, I have to find out what values would make it 0. So the value that would make this factor 0 would be 4. So I'm going to say x is equal to 4. That's one of the numbers I'm going to plot on that number line. And the value that would make this factor 0, x would equal negative 3. I'm going to plot that number on the number line as well, okay? Now, I'm going to do that number line. Let's do that number line right here. So I have 0, then I would have 1, 2, 3, 4. And then I would have, if I go to the left, 1, 2, 3. So those are the two values I need to check. I need to use to check the regions, which regions are true. Basically, we need to check any x value to the left of negative 3, in between negative 3 and 4, and to the right of 4 to find out where this would be true, what values of x would make it less than 0. Okay, so we could pick any number we want to plug in. That's in this region. Let's call this region 1, region 2, and region 3. Okay, so would negative 4 be in region 1? Yeah, that's to the left of negative 3. So let's plug in negative 4 and see if that works. And we'll see if it's true. So negative 4 squared minus negative 4 minus 12. Notice I'm replacing x with any value in this region 1 to see if it's true, if it really is less than 0. So negative 4 squared is 16, minus negative 4 is plus 4 minus 12, okay? And 16 plus 4 is 20 minus 12, which equals 8. And 8 is not less than 0. So that would be false in this region. The inequality would not be true anywhere to the left of negative 3. Okay? Let's check. When you're checking, if you can check 0, 0 is always something that's super easy to check. It's super easy to plug in. I could choose any number in this region too, but 0 is super easy to plug in. Because if I did 0 squared minus 0 minus 12 less than or equal to 0, well, I don't have to do much math. Those two go away. Negative 12 is less than 0, so it's true in this region. And then in this region, we can pick any value we want. This is 4, so any number that's bigger than 4 will do the trick. I think 5 is a good number. Let's check 5. Let's do 5 squared minus 5 minus 12 less than 0. So 5 squared is 25. 25 minus 5 is 20. And 20 minus 12 is 8. And that's not true. So it would be false anywhere in this region. So we're going to use what we have here. To express our solution, we're going to use interval notation. So it is true from -3 to 4. That's where this equation would be true. That's the values of x that would make this statement true. But would it include -3? Well, since it does not have an equal bar, it does not include -3 and it does not include 4. If it did have an equal bar in the inequality, it would include those numbers. So how can we write in interval notation that everything from -3 to 4 is a solution, but not including -3 and not including 4? We're going to use those parentheses. So -3, comma, 4, parentheses. So that is my solution, my values of x. Any value between -3 and 4, not including those numbers, would make that inequality true. All right, let's try another one. All right. Let's try 2x squared plus 5x is greater than or equal to 12. Okay, so with this one, we do have to get 0 on one side first. You want to keep your a squared positive. Let's minus 12 from both sides. And I get 2x squared plus 5x minus 12 is greater than or equal to 0. What method are we going to need to factor this so we can determine what would make it 0, so we can find those numbers on our number line? AC method, right? So AC equals -24, B equals 5. When two numbers multiply to -24 and add to 5, wouldn't that be 8 and -3? And then I put those two numbers over A2. And this one's simplified, but this one can simplify to 4 over 1. So my two factors, I'm going to continue right up here, would be x plus 4 and let's see, 2x minus 3. And we're going to find out what values of x would make those greater than or equal to 0. Remember, I did get it greater than or equal to 0. That was my first step. So the numbers that we're going to use on our number line, what would make this 0? I think it would be x equals -4. And what would make this 0? I think it would be, if I added 3 and divided by 2, it would be x is equal to 3/2. All right, so now we've got our numbers that we can put on our number line, and we can test the 3 regions and see where it's true. Okay. So if I checked, let's see, let's make this -4, 3, -2, -1. This would be 0 then. And let's see, 3/2 would be right in between 1 and 2. So 3/2 would be right there. If this is 1 and this is 2, 1.5 would be right there. So we're going to check anywhere to the left of -4, and we're going to check in between -4 and 3/2, and we're going to check the third region, which is anything bigger than 3/2. So we'll call this region 1, region 2, region 3. All right. So we can pick any number in this region as long as it's to the left of -4. We can plug it in to our equation here. I'm going to erase what I used to help me factor so that I can write that down. All right, I'm going to use -5 and see if it's true there. So if I do 2 and I replace the x with -5, squared plus 5 times -5 minus 12 is greater than or equal to 0. Let's see. So -5 squared is 25. So I have 2 times 25, which is 50, plus 5 times -5, which is going to be plus -25, and then minus 12. 50 minus 25 is 25, and 25 minus 12 is 13, is greater than or equal to 0. So then since that's greater than or equal to 0, it is true in this first region. It's true in this first region. So it's true here. The easiest number to use in the second region would be 0, because think about 0. When I replace this with 0, it goes away. When I replace this with 0, it goes away, and I'm left with negative 12 greater than or equal to 0. That's not true. That's not true. It's false. The solution is not going to be true in that middle region. There's no value in between negative 4 and 3/2 that would make this true. What do you think the third region is going to be, true or false? I'm dying to find out. Let's plug in 2. I think that would be a good, easy value to plug in. So let's do 2 times 2 squared plus 5 times 2 minus 12. And let's see if that's greater than or equal to 0. All right, so 2 squared is 4 times 2 is 8. 5 times 2 is 10 minus 12 greater than or equal to 0. Hi, I'm recording the video.
Okay, you have some tutors.
Tutors already? Oh, it's not until 6:45. All right, you can let them in.
Don't wait, come wait, you can let me
Yeah,
know you're done?
go ahead and let them in. Thank you so
Are you
much.
sure?
Yeah, I appreciate it. Thank you. Guys, I've got visitors. Okay, so 8 plus 10 is 18. 18 minus 12 is 6, is greater than or equal to 0. So it's true in this region. Okay, so I'm going to go ahead and erase this so I can write my solution in interval notation. And let's see, so it would be true anywhere to the left. So I want to start, the smallest value it could be is negative infinity, all the way up until negative 4. And since it's including negative 4 this time, I'm going to have a bracket. And then I'm going to union it, and then the next spot where it would be true again would be 3/2, but including 3/2. So we'll give it a bracket, 3/2, comma, infinity. Okay? So this is, I have guests. They're watching me. It's like a live studio audience. I'm so nervous. All right, so the solution will be anywhere from negative to negative infinity to negative 4. And then since it's not true in this middle region, we'll give it a gap, and then it's true again from 3/2 to infinity. And really, if you were to graph this, you know quadratic expressions or quadratic functions, when we graph them, we make a parabola. If you were to graph the expression that we said equal to 0, or greater than or equal to 0, it would be a parabola that crosses the x-axis at negative 4 and at 3/2 like that. So clearly from the parabola you can see that the values, the y values are above 0 anywhere to the left of this, and below 0 from negative 4 to 3/2, and then again above 0, okay? All right, hope you like it. This is an amazing lesson. And we've got one more for today, rational inequalities, and we'll get that one soon.